Welcome back, dear students. Today I'm going to teach you some new things about the exponential function. In this chapter, especially, we are going to discuss two subjects, and really they are very important. All the sections are going to work for serving really 4.5, which is the exponential and logarithmic function equations, and you are facing a challenge to solving these equations because you need more things, backgrounds about these all. So please be with me in this chapter carefully and focus on each section one by one. So we'll focus on exponential and logarithmic functions in this section 1. We are going to just introduce the exponential, which is related to each other. If there is a student can overcome and understanding the fundamentals about exponential function, will have a in the future or in the next section can solve or understand this one easily by like just 1 minute. You don't need more time really if you focus if you understand all concepts in the 4.1. So in the exponential function in the 4.1 we have what? We have exponential function. Yep, yes. In this one we have the important things is what the function is like that a of x and the graph of this example is very important. The differential say a greater than and a not equal to 1. The condition should be like that. It's not a problem for you. In the page 180 in your lecture note, you can just find these function examples on this one. For example, we have f of x is equal to 2 to power x. So we have what? We have natural sorry, we have a exponential function, exponential functions. Okay, dear. So, for example, if I have f of x is equal to 3 of x, can you imagine the difference between a polynomial and exponential? Polynomial is like that, but polynomial f of x is equal to, but in the exponential function you have f of x is equal to 3 to power x. So please pay attention and distinguish between them because they are very different in the meaning and in the graph. Okay, example 1 in page 109 is not include. So example 1 we are canceling the example 1 and its calculation because the solution because need a calculator. So this is just for you try at home. You don't need to study it, just try it. Okay, but the example 2 is very important because in the exam you will face something like that, and I'm going to direct to the example 2 in the page 109 in your lecture note. We have already sketched the graph. So in the 4.1 and 4.2, two things are very important. The first of all is what is the graph. Okay, dear. And the second, I think we have something here. Let me see. In the exponential of the graph, and the important thing is the property. So the graphs and the property are the basic things in in the chapter 4.1 to till 4.4. So we are focusing on these two basics, the graphs and the properties. So about the graph, now I'm going to the example 2. I'm going to so the example 2 about the graph. If you have we have what? F 109, we have f of x is equal to 3 of x. So the graph will be something like that. You have what? If I put 0, if x is equal to 0, I get what? I get 3 f of x is equal to 3 to power 0 is equal to 1. So it means that this point is the intersection, as I told you. If you want to find an intersection of y-axis with y-axis intersection, you should just let x to be 0 and you will get the intersection. So the intersection is what? When x is 0, I will get what? I will get 1. So this point will be our intersection. It's very important in the graph, and the rest of the graph will be something like that. Okay, nearing going to 0, but it's not intersect the x-axis. So it means that it's going to 0 without intersecting, means that it's going to minus infinity. In this part is going to up, is going to plus infinity. Okay, so when x is approached to positive infinity, the volume of x, the volume of y is increased also, something like. So this is the graph of 3 to power x. Okay, how about before I am going to part B, this example to part A, before I'm going to part B, I will try to solve another example for you. For example, f of x is equal to 5 to power or 6 to power x. Okay, I say just the graph. If I see just the graph, if I put x, I will get 6 to power 0 is equal to 1. So again, for all the points, I will get something like that. So if you see the difference between 3 to power x and 6 to power x, as the shape, they are similar to each other. As the shape, they are similar to each other. We cannot intersect x-axis, and this is going to positive infinity. And if you go into with this part, okay. Now I'm going to part B of example 2, page 109 in your lecture note, with the graph of f of x is equal to 1 over 3 to power x. You know that we can also sketch another another shape or another formula of this example, which is x to power minus 3. So you know, as you know, this one is because the negative is going to here. Or also we have another equivalent shape of some of this formula. You know, we can divide it, and we have also this formula. So most of or 3 of them, they are the same, they are the equivalent formula. So for the graph, I'm going to sketch it as if I put 0 here, I will get again what? I'll put again if I put 0, I will get what? For example, 1 over 3 to power 0 is equal to 1 of 1 is equal to 1. So it means that if I put 0, I will get also 0. But the shape in this formula will change to the other part. So we have the same shape, but in the other way, in the other face. So we have something like that. So if I will give you another example. If I say f of x is equal to for example 1 or minus 2x or 1 over 2x. So if I say sketch the graph, just do it easily, something like that. You have a 0 and 1, that's all. Okay, you need it. So about this example too, that's why I say very important, because also if you are going to this page, you fortunately you find the formula here. You can also find it. Okay, now I'm going to page 110, and you can see most of the shape are equal. So for in the example, if I say sketch one of them, for example, I say sketch 2x, you just do it like that. If I say 1 over 3, you will do it like that. If I say 2x, if you can imagine the positive parts are, most of them, they are the same. And for the negative part, when you have a ratio, you have things between 0 and 1, you can see we have the same. And all of them, the intersection is what are the 0 and 1. So that's the reason that I say they are very easy, and you can draw it as easy formula. And 4.1 really is easy section for those students that they want to control this subject. Now I have the same thing. If a is positive, your formula will be like that, as we mentioned, like for example, y is equal to 3 to power x. If x is between 1, sorry, a is between 1 means that 1 over 3, which 1 over 3 is between 1 of x. The formula will be like that. That's all, okay, dear. So that's all about the graph, and really this graph is I will leave this graph as challenging for you to understand the example 3. You need some thinking about the example, really. That's why I'm not trying to solve for you. And after this and you can see the solution. You can find how to find the if I give you the shape, solve for this, okay? If I give you the shape, I give you just the shape, how to solve, how to find the formula. I gave you just 2 and 25, so I say find the f of x is equal to what, okay? In the example 3, my question is what if I gave you 2 and 5, just find the formula of x, and you can see here directly in the solution you have what you have. A to power 2 is equal to let me solve for you. This for example 3. Example 3 in page 110 and 2111. Okay, in your lecture note. Now if I gave you just 2 and 25 and I say find f of x is equal to what formula, maybe in your exercise you will face these types of this type of the questions. So if I say, because I have two, so means that I have a, this is x, and this is y. So f of x is equal to a to power x. Why I see f of x is equal to a to power x? From where I brought this one? Because I knew it before that this formula is what is the exponential function. How about this one? This is an exponential function, but with what? But with a negative exponent, okay? Something like how about this one? This is the exponential with the positive exponent. So that's why I say f of x, and I will leave the second part for you. So I have this is y, this is x, so means that y is equal to ax. In other way, we have 25 is equal to a to power 2, and take the logarithm to both sides. You will get what? You will get easily a is equal to 5, because we took the square root. You can see we took the square root to both sides, and this square root and squaring, and 25 is equal to 5. So I got what? I got that we have a base is equal to 5, so f of x is equal to 5 to power what? 5 to power x. Okay, dear, that's all that you need to find the formula. I'll leave the second part for you, and you know why I told you why we say is equal a over 3 is equal to formula is like that. Okay, you can do it. Another example, really in the exam you will find something like that, and mostly in the final exam, before I bring one of them, because it's the manipulating the function. If you have the basic function, and now you are manipulating with it. Why? Because these techniques or this example need to use some of 2.3 techniques. Okay, so please try to review 2.3 techniques, with vertical shifting up to down, and horizontal shifting and reflexing outside, and reflexing with the inside. That's all together. That's why I say these are important, with what? With a little bit some new idea here that I'm going to give you. So in this part, if I in the example 4, It's very important. Again, I'll repeat it. G of x is equal 1 plus 2x squared. Now I want to sketch this one. I know the graph of this is like that. Y is equal to 2x. I know why, because if I put 1, I put 0, I get what? I get 0 and 1. In the exam, really, I'm concentrating on these points, okay? So, but here, I'm changing it. Why? If I put 0, I get what? If I put 0, I get 1 plus 2 to power 0, which is equal to 1 plus 1, and is equal to what? To 2. So, you should be careful that here you have 0 and 2, not 0 and 1. And your graph will still remains the same, okay? Still remains the same. And be careful, here you have asymptote دركنار. You have asymptote which says 0 is our asymptote, okay? 0 is our asymptote. It's going to there. How about here? I'm going to up one shift to vertical, so it means that addition outside the function. So I'm going to up. So this one in here won't be our asymptote in this graph. That's all. I think it's easy but need more concentrating, more idea. Okay, dear, that's part A. How about part B? The same example, the same page 111. Okay, in your lecture note. So in that case, if I say sketch the graph something like that, h of x is equal to minus x squared 2 to power x. So I have what? Careful, this is not equal to 2 to power minus x. This is another thing. I know the shape is like that. No, this is the inverse. And you know the inverse is where? The inverse is outside. When the inverse is outside, I have what? I'll just remembering you. If I have a y is equal to x squared, I'm remembering you slowly. Not in the highlighting things. If I say outside, I'll get what? We have the shape like that. So where is the mirror? X-axis is our mirror, okay? Axis is our mirror. So the same thing is true for here. I'm clearing this one because you know in the 2.3 you're controlling this subject, I think, in my opinion. So I have what? I have 2 to power y is equal to 2x, okay? Now change this one, reflects this one with the x-axis. Why I say reflects? Because x-axis is our mirror. So I have what? I have something like that. So this point is equal to what? Tell me just. This point is equal to 1. I know this is the original one, is what like that. So how about here? This point, I know, just put x to be 0, so I get what? Minus 2 to power 0 is equal to minus 1. So I know this point is equal to what? Is equal to 0 and minus 1, and that's all. Okay, that's all that you need to deal with it. That's all. Okay, and you know why? Because the minus is outside and x-axis is our mirror. Okay, dear. Now I'm going to another example. Okay, sorry, in the complete this last example in your section 2.1. We have what? We have c k is equal to 2 to power x minus 1. So in that case, it's very important, because in the exercise really you have something like that. Okay, the shapes are the same, or the this you find the same formula, same type of the questions. Okay, now I am going to do it. I know the original is like that, and there's going to 0 and 0 and 1. This is the original one. Now I have what? If I say in all the case, I say what? I say let x be 0. So I get what? I say k of x is equal to what? K of 0, let me say. So if you say 0 minus 1 was equal to what? Careful. Is equal to 2 power minus 1. Now 2 to power minus means that what? Means that 1 over 2. Okay, dear? So now if the original one is like that, okay, sorry, I'm going to infinity, which is 1 and 0 and 1. This is my y, 2 to x. Now the other part, or the other formula, is like that. I get what? When x is equal to 0, y is equal to 1 over 2. So it means that should be here, right? This is 1, this is 1 over 2. So I have the same shape, just going to down like that. That's all you need to sketch, okay? So in that case, I have something like that, okay? That's all. You should mention these points really. You should mention or write these points. Otherwise, I'm not accepting your answer. So please take care about these points, even in your lecture, not writing, but in the exam. I will really counting these points for you, and they are very, very important, especially on the asymptotes and the intersection lines. Okay, that's all you need: the shape, points, asymptotes. Okay, here 0 is asymptote, here 0 also, but maybe if I've adding 2 or something else, you will find the other example. Thank you for watching this section. Now next we have an exercise. Next we are going to 4.2. Have a nice time.